Let's get started. So I want to talk to you about latency, because I think latency matters more than anything in modern environments and what we experience as users. But before we get started, a bit about me. I'm from the Netherlands, father of 2 sons, and I've been with the Apache CloudStack community since 2008 or something, 2009, back when it was still cloud.com from Citrix. Also very active in the Ceph community. I am a IPv6 fanatic. So you'll see me talking a lot about IPv6 or blogging about IPv6, but that's a different topic, not for today. I work in the hosting industry. I'm currently CTO at YourOnline. We are a serial acquirer where we acquire all kinds of hosting companies throughout Europe, and we have a company here in the UK and in the US, so we keep acquiring companies. And my role as CTO is strategic, where I help our companies improving their deployments and improving their technology. This is a bit outdated ever since we did acquisitions in Sweden. In the meantime, one more in the UK, one more in Germany. We're always active with acquiring companies. Again, my work as role as CTO there. CloudStack at YourOnline, we got 2 very large deployments, one in Amsterdam and one in Valencia in Spain, and there's one coming up in the UK in Leeds at Hard Internet in the future. We're currently developing it. It's on its way, so hopefully next year I'll be able to talk about that we deployed CloudStack in the UK. But let's talk about latency, because I hope you understand what latency is about. Because we've got 30 minutes, and that's a pretty long period, or maybe short. But let's do a test. So everybody has a piece of paper. I think Yvette is handing out pieces of paper and pens. You need to write something on it. So either use a laptop so you can write on the piece of paper. I want you to take the pen. You just need to write one word. We're going to ask you to write the word CloudStack, and I'm going to time how long it takes to write the word. So when I say start, you start writing, and then you put your hand up when you're done. So when I see all hands up, I know that we finished writing the word CloudStack. Okay? So if everybody's ready. Yeah? Everybody's ready? Okay. Start. Okay, 8 seconds. 8 seconds. How many people here? How many people here?
We have to share a pen.
You have to share a pen. Okay, so there it goes. Make it 10 seconds. 10 seconds, that's easy to calculate. How many people we've had? Do we have here? 35. Okay, so that means that in 10 seconds, we could write 35 words. So our throughput is 3.5 words per second. But the individual latency for writing a word is 10 seconds. Time is the ultimate currency. Anybody seen the movie In Time?
Yes, good movie.
That's a very good movie. Yeah? I think it's the ultimate currency. So we had a throughput. We had a lot of throughput, and I think there's a lot of emphasis always on throughput. So you can say, we have a throughput of 3.5 words per second. That's great, and maybe we can double the throughput by just adding more people. If there would be 70 people here in the room, the throughput would have doubled. But the latency for writing an individual word would still be 10 seconds. Would still be 10 seconds for the single word. So imagine you're waiting in a room, and somebody is filling out a form for you. 30 people in a room, each filling out a form. You have to wait for that single form to be filled and the signature on there or a stamp on there. And it takes them 15 minutes to finish. You're just waiting there idle for 15 minutes. There might be a high throughput, 120 forms per hour. The throughput seems like a great number, but you are just waiting and waiting and waiting. Waiting, nothing happens. Form is finished. I can continue my work because I needed to wait for that form to complete. Let's say you're a delivery driver and somebody needs to fill in a form and put a stamp that you delivered your stuff, and you can go again. 120 delivery drivers per hour, but the latency for the individual driver is 15 minutes. So do you want to wait 15 minutes, or would it be great if your latency goes down to 5 minutes? The throughput could still be the same, you'd simply have less people writing forms, but the latency would go down. So bandwidth is great. But latency, I think, is something which always matters. There's this hyper focus on bandwidth. Networking, we need to go to 100 gigs, to 400 gigs. Your ISPs are now marketing that you can get a gig synchronous of fiber to your house, or maybe you can get 10 gigs now. Everybody goes for more bandwidth. But then they're still using Wi-Fi or Wi-Fi 5 or crappy connections, and nobody focuses on latency. Because why would you care? Why would you care about latency? If you take Netflix, you hit play. You want it to start instantly. That's latency. If you're online gaming and you want to hit somebody in the FPS, that is latency, not bandwidth. Add to cart in a shopping cart. Yeah, in your cart. Again, that's latency, what we're talking about. So many things, but all of these things benefit from having a lower latency. There is research that if you go to a web shop and the time to first byte, as we call it in the hosting industry, so whenever you hit on a page, refresh or click on a link, then the first byte is being served to your browser. If the latency goes down by 100 milliseconds, the conversion ratio of that web shop goes up. Because we as humans actually think it works better. It's a better web shop to work on, to shop in. And that's why you see all the major shops just working on lowering their latency, We in the hosting industry, we do not push that much bandwidth to the internet. Our average company does 20 gigs per second, maybe 30 gigs per second. And again, everybody's talking about the volumes of traffic going over the internet. That is Netflix, that's YouTube, that's all the big CDNs pushing a lot of data, a lot of bandwidth. But most of our customers benefit from having a lower latency. And I think you also benefit from a lower latency. I found this on the internet. Of course, thank you, Google, for giving the images. The bandwidth in the truck carries way more cargo and data, but the latency of getting the data to you takes a longer time. The car is much faster. Lower latency getting to you. Once the truck starts moving, the bandwidth is enormous. You have seen these calculations maybe that they say if you take a truck and put it full of hard drives and drive it from A to B, the bandwidth of the truck moving down a highway with data, enormous amount of bandwidth, super high latency. So if it would ask you, you can choose connection 1 or connection 2. Which one would you choose at home? Which one would give you the best experience?
2.
Connection 2 would. Yes, indeed. If you want to download this game with your PlayStation of 200 gigs, it will take longer on their 100 megabit connection. But for day-to-day usage, connection 2 would be much nicer to work with than connection number 1. Although everybody focuses, I got a 1 gig connection, awesome. Yeah, Starlink, for example, is nice, but it has a latency of 30, 40 milliseconds, while fiber to the home gives you 2-3 milliseconds, usually of normal latency, or maybe sub 10. That's a huge difference. If you're using SSH and low latency, if you hit a button on your keyboard and instantly it's there, it just feels nicer for us. We notice latencies as humans below 100 milliseconds. It's stuff which we notice. Although we don't actively notice it, we do subconsciousness, we notice if it's more snappier. So how does it affect your CloudStack deployment in real life? Let's start with the speed of light. In a vacuum, it travels roughly 300,000 kilometers per second. So about 7 times around the Earth in 1 second. But we have fiber optic cables in data centers. Speed of light on them is about 200,000 kilometers per second in a fiber cable. Light bounces, so it actually travels a longer distance through the cable as it bends and the cable goes around and the light refracts through the cable. There you could say that every kilometer of fiber adds about 5 microseconds of latency to the network. Every kilometer of fiber. Within data centers, there might be a lot of cabling, even cabling you do not control. If you get a fiber between 2 data centers, somebody routes that fiber for you to different locations. Long distances of cables, it all influences. And then you have gamers just screaming that the latency is too high. I'm almost turning 40. I play Battlefield 1942. I would always pick the gaming server with the lowest latency because that would give you the best experience. Back in the days, I had my own Battlefield server in the data center. I would be next to my server and then other people joining. Hey, who would win? Who would win? Again, the concept of latency I want to talk about. So shortening the fiber length stuff, it all influences things. And then we build all these awesome things with network translation between data centers, fibers in between routers, switches, all that kind of stuff. But everything takes time. if you look at a router, this is a Juniper box, and you put an SFP, which converts electrical to optical, and back again, it takes time. Everything you add in the network takes more time. We start building out all these kinds of things. APIs, SQL databases, caches, all these beautiful network designs, more cables, more things in between. We keep adding latency to the environment. But again, how does it affect your CloudStack deployment in real life? Well, if you look at disk I/O, writing something to the disk, local storage, it varies here. I use a Ceph environment, you can use store pool, you could do all kinds of things. Local storage on a local SATA SSD, simple hypervisor I tested, about a third of a millisecond of writing a single 4K block. Whenever I do a benchmark for storage, I benchmark writing a single 4K block to the disk. I never benchmark high queue depths. If you go for SSDs, they always say, we can do 1 million IOPS on that single SSD. Yes, that's true. A lot of concurrency. But you'll see that in real life, most of the applications are not concurrent. We can go for high core count on CPUs, same thing. Many applications still run on a single core. They benefit from single core performance. And that's also latency. The higher the frequency of a CPU, the more it can do in a single clock cycle, the faster it is. PHP code, for example. A lot of the PHP code is still single-threaded, benefits from lower latency. Ceph storage, there, 3-4 times slower writing the single 4K block. You will notice in your application. Local storage is faster, but it's also, latency is lower, but it's also less redundant. Pick 2 out of 3. You cannot have all 3. So latency for storage, simple piece of PHP code. Now imagine writing 1,000, 10,000 or 1 million small files to the file system. Who has used rsync? Who has tried to use rsync with millions of small files? That benefits from a low latency. The lower the latency, the faster your rsync is. Doing the differentials between the changes, network latency, and then starting the sync latency again. Not bandwidth, latency. Or just Redis, PHP code again. Local host, 0.1 milliseconds of latency. That's an example. And a server in a different data center, 1.5 milliseconds. Well, that will take you either 100 milliseconds to write 1,000 keys into the Redis database, or it'll take you 1.5 seconds to complete. This could be a user waiting on a web shop to actually place an order, do something, and want to get the confirmation that it was done. On LinkedIn, I read this post a few weeks back where somebody said, you should know this world. I ran on AWS, I run my SQL server in Frankfurt, and I have my API server in Dublin. And by moving them in the same data center, my application got so much faster. I was like, yeah, duh. Yeah. Latency. But it's a misunderstood concept. There's always the focus on bandwidth, not on latency. Again, network latency, so you want to do an insert into a database. If you put that database server far, far away, the insert will take just a lot longer. And then if we start abstracting that the VM is running on network storage, any network storage just introduces more latency, you will have a slower SQL database. And then we say, we're going to replicate 3 times all the data. Take a MariaDB Galera cluster or something else. If you want to do a synchronous write between, you have to wait for all the replicas. And if there's more latency between them, it will just take longer to insert. My main point is, there is no cheating with this. Laws of physics tell us that there's latency for anything we do, and you have to take this into account when building and running your environment. But again, how does it affect your CloudStack deployment? Developers love to do this kind of stuff. Application API with another API, microservices scattered around VMs everywhere, small databases, super easy to maintain for them, different repositories, all a swarm of VMs, and suddenly there's latency everywhere between all the different servers because they are scattered around on different locations. In a place far, far away, there's a user. On host A, there's the application. On host B, there's an API running where the application talks to, and then X, Y, and Z, we have the different APIs and different databases running, maybe even in different zones, different locations, latency. It just gets slower and slower and slower because there's latency everywhere. And why? I'm not bashing developers here. They have their MacBook, works on my MacBook. They start complaining that production is slow. No, production isn't slow, it's simply obeying the laws of physics. But they have a beautiful MacBook and so fancy. It works on my MacBook just expected. And then they go into production. I've been saying on a CEF conference that I think we should give developers a spinning disk again in their laptop. And make it work on the spinning disk. And then you can go into production. But don't give them the fancy NVMEs when writing applications. So the thing I want to tell you is that what can you do in your deployment? Deploy VMs close to each other. Use host affinity grouping that certain applications run on the same hypervisor. I do understand that there's redundancy involved here, but we have HA, so the VM can start somewhere else. But if you group them together on the same host, you will reduce your network latency. Same goes if you're using a VR, all the translation within the VR introduces additional network latency. It's great that you can have VPCs with VRs and have the separation, but you keep adding more latency when traffic goes through packet inspection, goes out, goes in again. And it's something you notice. It's something you notice very well. Within our group, we have companies who run Magento web shops. And they say we pack everything, database, Redis, and web server within the same VM. And they sometimes still even run on bare metal. That gives the best performance and the best experience for the end user when using that web shop or some other application. Use local storage if possible. Again, there are drawbacks of using local storage, but think about there might be applications where it can work and would just be better. But do understand that if you write something to storage, it is expensive. Capacity on a disk is cheap nowadays. You can buy any big disk and you just have capacity. But if you want to have low latency, that is expensive. I/O is expensive, storage is cheap. Keep that in mind, any I/O. For example, a discussion I had a few years back with somebody from Frankfurt. I've noticed it mentioned a few times. They were using dark fiber between two data centers, and suddenly the performance went down, and there was maintenance on the fiber, and there was rerouted the fiber 20 kilometers of additional fiber length between the two data centers. Latency just went up, application performance dropped down. So remember, every layer you add adds latency, and bandwidth doesn't matter, latency does. That is my main message, what I wanted to give you. And with everything you do, do not go crazy on just getting more bandwidth. Latency, latency, latency. And that's what we notice as users. So, that's all.
Any questions for you?
It was all clear? That's good. Oh, please.
Do you see a transition when it comes to cabling and stuff? I read something from NVIDIA where they say they go all copper instead of fiber because of latency. Do you see this in normal data centers?
What you see is that within DCs, for CEF storage, for example, I see that a lot of them are sticking to copper, indeed, because it reduces with a couple of microseconds of latency. And reducing cable length. I think that is something to keep in mind. Adding more cable length adds latency, and it's fairly easy to do when you're deploying and designing, just routing the cables as short as possible. And we think that it's just a few microseconds, it's fine, but it keeps adding up. But the main thing is that software layers keep adding more and more and more. There's this whole trend of that saying, oh, monolithic applications are not allowed because they're bad. Well, they are usually much faster. So microservices are great, Kubernetes is great, but it's a latency hell of running Kubernetes. Because then you have VMs spread out within CloudStack and then containers being spread out within those VMs. You have no idea anymore of the latency. For us as a human, a millisecond of latency doesn't seem that much. And if the latency then goes down to 0.5, like, what's the difference, a half millisecond? No, it's 2 times the difference between the two. So So keep it in mind, keep it in mind.
I don't know if this is relevant or not, but you did mention software like that. Is IPv6 more performant than IPv4 in any way?
No, they're both. Yeah, there's one difference though. With IPv4, we're doing a lot of network address translation, NAT. That adds a bit of latency. But if it's pure routing, V4, V6, performance is equal. Yep.
Any more for Guido? Great, thank you, Guido.
Thank you.